Okay, now today we are going to discuss hypothesis testing, that is from the Elementary Statistics by Bluman PDF, and we are going to discuss chapter number 8, page number 339. Okay, now we know that statistics can be divided into two categories. One is the descriptive statistics, where you are supposed to get the variance, standard deviation, average, and so on. And another kind of statistics is known as inferential statistics, where you are supposed to do some forecasting. We can do some interpolation, extrapolation, and that will be there. That means you are drawing some conclusion or inference, and that's why it is called inferential statistics. So we are starting with that scenario. So now let me start with this chapter. Very good book. You can go through this particular chapter line by line, but let me discuss the core points in this class. A statistical hypothesis is a conjecture about the population parameter. The conjecture may or may not be true. That means you are making some conclusions on the respective population. So let us suppose a statistical hypothesis is a conjecture about a population parameter. This conjecture may or may not be true. Okay, so that is a hardcore definition of hypothesis. If you go for dictionary.com and if you want to find the the meaning of the word conjecture, so they are giving two very important terminologies. One is the evidence for proof, and another one is the speculations. So obviously they are also agreeing with this point that without having sufficient efficient or proof, whatever the formations or expressions of an opinion or theory without sufficient evidence for proof. So that is known as the conjecture. Okay, let me return back to the PDF. So now the thing is that a statistical hypothesis is a conjecture about a population parameter. This conjecture may or may not be true. Good. This hypothesis can be divided into two categories. One is the H0, another one is the H1. The null hypothesis, symbolized by H0, is a statistical hypothesis that states that there is no difference between a parameter and a specific value, or there is no difference between two parameters. So that is the null hypothesis they are telling. I know that conception will get cleared if I go for certain examples demonstration. The alternative hypothesis, symbolized by H1 in the suffix I'm getting 1 here, is a statistical hypothesis that states the existence of a difference between a parameter and a specific value, or states that there is a difference between two parameters. So obviously null hypothesis and alternative hypothesis, they are stating two contradictory making two contradictory opinions. So in the null hypothesis is telling that there is no difference regarding a specific value. You might be asking me, what is the specific value? The specific value may be the mean of two samples. Let us suppose from the population, you have taken sample for 100 people. You have taken sample from different zone of the population for another 100 people. So the mean of this 100 people taken from a population zone and mean of this 100 people taken from another population zone. In null hypothesis, I'll be stating that these means are equal. There is no difference. But in case of alternative hypothesis, we'll be stating that the means are differing. So that is the issue is there. Let us suppose we are having bodybuilders. They are doing gym work at some gym. Okay. So the thing is that let us suppose they are taking some, how should I say, some health tonic. They are taking some health tonic. Some of them are taking some health tonic and some of them are not taking the health tonic. So now my null hypothesis is telling that the average weight, the mean weight of some set of bodybuilders who are taking that health tonic is same as the sum of the sample of the bodybuilders who are not taking health tonic. So I'm making this hypothesis as a null hypothesis. In alternative hypothesis, I'm telling that that very population who is taking health tonic, their weight is higher than the set of samples taken from the population not taking the health tonic, is they are differing. The mean of their weights are differing. So that is known as the alternative hypothesis. Considered the main notion behind this null hypothesis and alternative hypothesis. Good. So let me come to the point. A medical researcher is interested in finding out whether a new medication will have any undesirable side effects or not. The researcher is particularly concerned with the pulse rate of the patient who is taking this particular medicine. Will the pulse rate increase, decrease, or remain unchanged after a patient takes the respective medicine? Since the researcher knows that the mean pulse rate for the population under study is 82 beats per minute, the hypothesis for these situations are mu is equal to 82 in case of null hypothesis and mu is not equal to 82 in case of alternative hypothesis. And that is the thing is this. That is the thing. Now we are coming to the next point. A chemist invents an additive to increase the life of an automobile battery. If the mean lifetime of the automobile battery without the additive is 36 months, then her hypothesis are mu is equal to 36. After editing the additive, the life is remaining the same, and we can tell that mu is greater than 36. Because obviously that they are demanding that using this additive, the life of the automobile battery will increase. So that's why I can write mu is greater than 36. Similarly, for this, a contractor wishes to lower heating bills by using a special type of insulation in the house. That means if you have enough insulation in a certain pipe or through which the hot water or the hot air is blowing, so if you have the enough insulation, then obviously the heating bill, the electricity bill to make the thing warm, obviously the bill will reduce. Yes, now here mu is should be less than $78. So that is the issue. So we can have equal to, we can have greater than, we can have not equal to, we can have less than. Whenever we are having the greater than or less than, we can call it as one-tailed or one-sided hypothesis. And when you are telling not equal to, then it is becoming two-tailed or double-tailed, T-A-I-L-E-D, two-tailed or double-tailed hypothesis. So now they are writing the same. 80. Mu is equal to K and mu is not equal to K. Two-tailed. Right tail high test is mu is equal to K. Mu is greater than K. Left tail means mu is equal to K and mu is less than K. So this is the notion they'll be using this one. So two-tailed, right-tailed and left-tailed. So three tests are there. বলে পড়ে পড়ে হ্যাঁ good good ঠিক
means that whenever we take null hypothesis, that will not identify.
No, actually, in the null hypothesis, always we take the equality. But in the alternative hypothesis, we usually write not equal to, greater than or less than. So two-tail test ki right tail ki left tail, এটা কিন্তু alternative hypothesis এর উপর ডিপেন্ড করতে হবে। সবসময় কিন্তু মেন যে null hypothesis সেটা আমরা ধরি যে সেম আছে, আমি ধরি সেটা সেম আছে। ঠিক আছে, শুনুন না, কোনো হ্যাঁ two-tail test মানে হচ্ছে এই ক্রিটিক্যাল ভ্যালু থেকে বড় অথবা ওই ক্রিটিক্যাল ভ্যালু থেকে কম। হ্যাঁ হ্যাঁ যাবো যাবো আচ্ছা তাহলে
not equal to left tail either equal এটা কেন two-tail test either equal either not
equal to হলে পরে বড় হতে পারে, বড় থেকে মানে ক্রিটিক্যাল ভ্যালু থেকে বড় হতে পারে, ক্রিটিক্যাল ভ্যালু থেকে ছোট হতে পারে, নট ইকুয়াল। আর যদি আপনি গ্রেটার দ্যান দেন ক্রিটিক্যাল ভ্যালু থেকে বড়, আর যদি লেস দ্যান দেন ক্রিটিক্যাল ভ্যালু থেকে ছোট, এটা পার্টিকুলারলি আমরা বুঝতে পারছি।
আমি গত দুটো ক্লাস খুশি হয়েছি ক্লাস ইউজ করতে আপনাদের সামনে আজকে আমাদের পরীক্ষা কি সকালে আর আগে এক্সাম words of that is put together.
Something of someone else. What about
चलो. So now, बोले.
tell me about the value, real value, whenever we will take the like 10 test or the tutorial test, what would be our significant level and what would be the confidence level?
এই তো পড়ে সবই আরম্ভ হয়েছে, 2 পাতা পড়ানো হয়েছে. He is having at least 40 to 50 pages in this chapter. Let me cover everything will be coming. Such a nice book, this one. Okay, now we are going for the next section. So let me come to one point. Now let us suppose H0 is true. Let us suppose we are having, it is mu x is equal to 82. Mu x is equal to 82, and H0 will be true if the respective mu x is equal to 82. That means just equal to the respective value. So let it be the pulse rate. So if mu x is equal to 82, so that is the pulse rate after taking the medication, then also the pulse rate is remaining the same. If it is so, then I can say that H0 is true. But here you see this particular mu x is not equal to x bar. This particular mu x is not equal to x bar. So in this case, what will happen? The null hypothesis will become false. The null hypothesis has become false because it is not equal to 82. 82 is here. Mu x is something at different place. So that is H0 is equal to false. Now if you consider this particular example, so mu is equal to 82, that means the average pulse rate is 82. After taking the medication, then the average pulse rate of the population is still 82. So that is the demand opinion from the H0. In case of H1, I'm telling that mu is not equal to 82. That means after medication, the pulse rate will change. Good. Now in the pictorial diagram, they have shown that if mu x is equal to 82, if it happens, then null hypothesis is true. But if mu is there and 82 is there, if it happens, then the null hypothesis is false. Good.
So why we compare this to be?
One where the null hypothesis is true, the mu is still, it will be equal to 82. Here mu x is this one, but 82 is this one. So they are not equal. So null hypothesis is false. Only to show that when the null hypothesis is true, how the sample distribution curve will be behaving, and when it is false, how does it behave? Just for showing.
There is the mu x is the
A statistical test. We are having different kinds of test. I told you Z test, T test, F test, chi-square test. So a statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. The numerical value obtained from a statistical test is called the test value. So that statistical test will indicate whether I should accept a null hypothesis or I should reject that one. And the numerical value obtained from a statistical test is called the test value. Okay, let me come to the point. So that is very important. Type 1 error and type 2 error. Type 1 error is that whenever there is a situation where null hypothesis is true, but my conclusion says it is rejected. That is known as a type 1 error. Type 2 error is there where null hypothesis is false, but my conclusion is that don't reject null hypothesis, accept that one. And that is known as a type 2 error. In case of null hypothesis is false, reject null hypothesis, that is the correct decision. Null hypothesis is true and do not reject the null hypothesis, that is the correct decision. So type 1 error means when the null hypothesis is true, but my statistical explanation or processing states that the null hypothesis should be rejected. So that is known as the type 1 error. And when it is false but I am accepting, not rejecting, then that is known as the type 2 error. So type 1 error and type 2 error, two types of errors may happen in the statistical analysis. A type 1 error occurs if you reject the null hypothesis when it is true. The type 2 error occurs if you do not reject the null hypothesis when it is false. So these two errors are there. Questions might be coming, what is the type 1 and type 2 error? So easy questions might not come, but probable questions are like this. So what is the type 1 error and what is the type 2 error? Good. The conception of type 1 and type 2 error is not clear to us. Please try to come to this particular example. Let us suppose there is one person on which a murder charge has been assigned, has been charged. He has been sued for that. So one murder charge has been assigned. 80 says, the null hypothesis says the person is innocent, not involved with the murder. Now, if the person has got convicted for that, the person has become convicted for that, then it is called type 1 error. That means without doing any murder, the person is getting the punishment. So that is a type 1 error. Now really the person is not innocent, he is really involved with the murder. But my ultimate judgment says that he can be acquitted. That means released. No murder charge on him. And that is known as a type 2 error. So that's why if the person is innocent, but you are punishing him, type 1 error. If the person is convicted, if the person is not innocent, but you are releasing the person, that is your type 2 error. Now I am coming to the next issue. The level of significance is the maximum probability of committing a type 1 error. This probability is symbolized by alpha, Greek letter alpha, that is P. Type 1 error is equal to alpha. So level of significance is the maximum probability of committing a type 1 error. Please see on the screen. The level of significance is the maximum probability of committing a type 1 error. What is the type 1 error? 80 is false, but I am accepting it. So that is known as the type 1 error. This probability is symbolized by the word alpha, and that is P of type 1 error is equal to alpha. So that's why I was telling P value. P value means P of occurrence, probability of occurrence of type 1 error, and that is equal to alpha. That is the level of significance. The probability, say in Excel, when you shall go for ANOVA, analysis of variance, then if you do the T test or if you go for the F test, you cannot see this word significance, level of significance. But in your exam question, it will be asking you, what is the level of significance? So please remember, when they will be asking to give you the level of significance from the ANOVA output or from some other F test or chi-square test output, you should have to copy the P value and then paste it in the exam software. So P value means the level of significance. Remember this one, please, because in the Excel output you shall not get the level of significance this term. You will be getting P value. So P value means level of significance. The probability of type 2 error is symbolized by beta. The probability of type 2 error. What is the type 2 error? Null hypothesis is false, but you are accepting that. So that means the person is a murderer, but he has been released. So that is a problem. So here the symbol is called beta. There is a Greek letter beta. That is P of type 2 error is equal to beta. In most hypothesis testing situations, beta cannot be easily computed. However, alpha and beta are related in that decreasing one increases the other. So that is the issue, obviously. So that is beta and alpha. So if you go on doing the summation of that, and that is giving you the 1. So if alpha is increasing, beta is decreasing, and vice versa. So now we are having statisticians generally agree on using 3 arbitrary significance level, that is 0.1, 0.05 and 0.01. So we are having 3 significance levels. So statistician, they used to consider three significant levels, that is the common practice. And these are 0.10, 0.05 and 0.1. I'm not getting what is the issue. Issue is that it is 10%, it is 5% and it is 1%. So it is nothing but 10%, 5% and 1%. So that is the common practice. We used to consider this significance level of 10%, 5% and 1%. So that is the common practice nowadays. So 10%, 5% and 1% they are telling. Okay, so now we'll be considering the critical value. Now we are going to discuss the critical value. Critical value separates the critical region from the non-critical region. The symbol of the critical value is CV. The critical or rejection region is the range of values of the test value that indicates that there is a significant difference and that the null hypothesis should be rejected. Non-critical or non-rejection region is the range of values of the test value that indicates that the difference was probably due to the chance that the null hypothesis should not be rejected. I mean, critical value হচ্ছে একটা demarcation between the critical region and the non-critical region. Critical region এ যদি কোনো ভ্যালু পড়ে আমি তাকে রিজেক্ট করব, নন ক্রিটিক্যাল রিজনে যদি ভ্যালু পড়ে আমি তাকে রিজেক্ট করব না এবং নাল হাইপোথিসিস কে আমরা অ্যাকসেপ্ট করব, রিজেক্ট করব না. So now let me go for the actual case studies. নিশ্চয়. So now we are going for the actual to the point how to calculate the critical values. So issue is there. How to calculate the critical value? So at first we are going for the right tailed test. Right tailed test means the critical value will be belonging on the right hand side of the mean. Good. Tell me. Alpha is equal to level of significance is equal to 0.01, that is 1%. Means hypothesis will be null hypothesis will be and type 1 error occurrence probability is 1%. Please try to get me. Occurrence of type 1 error. What is the type 1 error? Null hypothesis is false, but I'm accepting that one. So occurrence of null hypothesis error, type 1 error is 1%. That means not 1%. That means 0.9900. This is the corresponding respective area where I'm accepting. I'm not doing the type 1 error, but for 0.01 I'm doing the type 1 error, and this Z is actually denoting the critical value, and that is known as the critical region. Now see 0.9900. In that case, what will happen? Please come to the respective other editor where you have opened the Z table from the same ebook Elementary of Statistics by Blumen. I'm coming to the page number 783. I'm opening the same ebook in another editor of the PDF reader rather. So please try to search a value. That is, what is the value I'm searching for? Let me know. 9.9900. Please come and search the value. 0.9900. I'm getting this one. Here, this value is very close to 0.9900. Please try to get me, please. This value is very close to 0.990 because it is 9898. That means it is 0.0002 difference from 9990 and it is 0.9904. So it is 0.0004 increased. So that's why it is the very nearest one. So it is 2.3.03. So please go on adding. It is 2.33 is the critical value. So let me come to the other PDF and the value I'm searching for this in this way, and then my critical value has become 2.33. So that is the right tailed. So let me come to the left tailed. So similarly I'll be having the same, because again we are having 0.01 here. So the non-critical region is 0.9900. So that's why here the value will be negative. So that is minus 2.33. So in the same way I can calculate. Now please come to the two-tailed test. Please come to the two-tailed test. So here also the level of significance I have considered 0.01. 0.01 is the probability of occurrence of the type 1 error. So you see this particular 0.01 must be divided into two sectors, two zones. So individually each one of them will be 0.005. There is a 0.005. So this is the range. Whatever we are having is 0.9900. And if you consider this critical value, we are accepting this. So this is 0.9950 and the critical value will be calculated accordingly. So not getting the issue. Good. Please try to find out 0.9950. Please come and find out 0.9950. Please tell me what should be the value then. I can take this one, I can take this one. So that is 2.57 and 2.58. So there, what are the value they are taking? What are the value they are taking? 2.58. Yes. So they are taking the value 2.58 plus and minus. So similarly, it is accepting in this way. So now in this case, if we consider this one as 0.5, if we consider this one as 0.1 rather, 0.1, that means it will become 0.900. It will become 0.900. So here if we go for this 0.900, this value is very much close to that. So the respective critical value will be 1.28. The respective critical value will be 1.28. So in this way I can do the calculations for the all significant values. So that is the issue. So in this way you will be doing the rest. So respectively they have done all the values, they got calculated and they got listed for the left tailed, right tailed and two tailed. How to get them? If you forget, you can directly search on the Z table and get it done. So in this particular page, all the critical values for three different level of significance for three types of two tailed, one tailed. So they have made a summary here. So here we have consulting Z table. So I think rest part we can easily do, and at home you can do the practice, please. So let me come. Now we are going to discuss the Z test for mean. For a mean, the Z test is a statistical test for the mean of a population. It can be used when the sample size is more than equal to 30, whatever you are telling. Sample size is more than equal to 30, or when the population is normally distributed and sigma is known. So that is very, very important. Z test and T test. Remember, Z test will be applicable when standard deviation is known to us. T test will be applicable when you know only the average. Standard deviation is unknown to us. So please try to get my issue. Why? Because in the respective Z value calculation, I require the standard deviation taking participation here, and this sigma is denoting the population. So there is a population standard deviation we should know. We know that population standard deviation should be denoted by this sigma, and sample standard deviation should be denoted by S. Population mean should be denoted by mu, and sample mean should be denoted by X bar, and that notational convention has been followed in this particular PDF. Good. So that is a Z test, is a statistical test for the mean of a population, and here the sample size must be greater than equal to 30. So statistics says in this way. So let me come to one example. A researcher reports that average salary of assistant professors is more than $42,000. A sample of 30 assistant professors has a mean salary of $43,260, which is more than this average salary for the population. And alpha, that is the level of significance they are considering as 0.05. Test the claim that assistant professors earn more than 42,000 per year or not. The standard deviation of the population is $5230. So here the null hypothesis will be mu is equal to $42,000, and the alternative hypothesis will be one-tailed. Why one-tailed? Because here the population, the sample salary, mean salary has become 43,260. So obviously in the claim of the alternative hypothesis, it should be the population mean must be greater than 42,000 because 43,000 is greater than $42,000. So find the critical value since alpha is equal to 0.05 as it has been considered, and test a right tail test, and the critical value is z is equal to 1.65. So now I'm calculating this one, I'm getting 1.32. So now you see 1.32 is quite well within, please try to get my issue. 1.32 is quite well within this critical value 1.65. So that's why I should make the decision that since the test value is equal to 1.32 and it is less than the critical value, that is 1.65, and is not in the critical region, so decision is not to reject the null hypothesis, and that is the decision they are making.